I'm Ramon Benavides. I'm with the MAT Science program at the University of Texas at El Paso. Today I'll be presenting my interpretation of the perfect geological storm, which is Confusion Hill. I'll begin with some background information about the Franklin Mountains and about Trans Mountain, and then talk a little bit about the geographical composition of Confusion Hill, and then begin my story on how this perfect storm came to be. The Franklin Mountains are positioned at the southern tip of the American Rockies. They're a linear range, and they run north and south through New Mexico all the way down to our city of El Paso. Here we have a road map displaying all of El Paso's major roadways. Prior to the construction of Trans Mountain Road, the only route to West El Paso was I-10. Trans Mountain Road cuts through the Franklin Mountains. Our perfect storm, Confusion Hill. Confusion Hill is the first outcrop as you're driving along Trans Mountain Road from northeast El Paso to far west El Paso. The outcrop was exposed during the construction of Trans Mountain Road in the late 1960s, early 1970s. As you can see, all the different rock formations, all these rock formations date back to the Precambrian periods. Here you'll find three of the major rock formations which make up the Franklin Mountains. I'll start off with the oldest of rocks, which is the Kastner Marble. Then you have your basalt, the Mundy Breccia. And finally, the youngest of the rocks, the Red Bluff Granite. As you can see in the hill, you see younger rocks cutting through or cutting across the older rocks through dikes and sills, and then you also have a lot of xenoliths, older rock trapped within the younger rock. How did all this occur? Well, let me tell you. In a perfect world, these rocks would follow the law of superposition. You would have the oldest rock at the bottom and the youngest rock up the top. Kastner Marble and the Mundy Breccia are the youngest. They were formed 1,260 million years ago, and the Red Bluff Granite 1,120 years ago. Once again, in a perfect world, these would be layered according to the law of superposition, but at Confusion Hill, they create a perfect storm. We will go ahead and start off with the oldest of rocks, the Kastner Marble, which dates back to 1.2 billion years ago. Rock that was transformed through contact metamorphism. The marble has several layers with quartz crystalline structures. You can also see some limestone layers and mud-rich layers. These muds and limestones were deposited as a result of a shallow beach. Here we have the Mundy Breccia, which is a basalt. This rock is a result of a catastrophic event, and there's no real time gap between the Kastner Marble and the Mundy, so they were both about the same age, about 1.2 billion years old. The Mundy is an extrusive rock which cooled extremely fast. You have Mundy that cooled forming hexagonal columns, as you can see here. And then you also see columns going into the hill, which you'll also see here. And then you have the Mundy, which actually displays some type of flow, which you have here. Then you have your pieces of Mundy, which are scattered across the hill, and these are xenoliths, which are older rocks, which are trapped within younger rocks. Finally, the youngest of the rocks, the Red Bluff Granite. This Red Bluff Granite has about 5 intrusive stages, and it can be dated back to 1.1 billion years ago. Stage 1 is the oldest, and it can be found as sills running along the layers of the Kastner Marble, as you can see here. Then you have your Stage 2. Stage 2 is a homogeneous granite. It's a biotite amphibole alkali feldspar granite, and which makes up 80% of the granite found in the Franklin Mountains. Stage 3 has medium quartz grains and is massive in form. It's a biotite amphibole alkali feldspar quartz sienite granite. Then you have Stage 4, which can be found as intrusive dikes. This leucocratic biotite alkali feldspar granite can be seen intruding older intrusive units. Finally, you have your Stage 5 granites, which is the youngest of the granites. It's banded in layer, and it's pegmatic, and you'll see alkali feldspar quartz crystals reaching over 5 centimeters long. Before we begin to examine the details of Confusion Hill, let's take a step back and take a look at the bigger picture. Here in this picture, let's take a look at it and see the geographical composition of this portion of the Franklin Mountains. And also let's take a look at this picture and observe the different formations found around Confusion Hill, which Confusion Hill is found at the base of this mountain. After looking at these two pictures, it allowed me to better understand
and get an idea of what exactly happened in Confusion Hill. So how did Confusion Hill end up like this? As you can see, there's several illustrations here trying to explain that. And there's several possibilities that I will go ahead and talk about in the next few slides as to how Confusion Hill ended up as a big old mesh of different rock formations. So what happened here? Well, I have it down as a whole lot of everything. As you can see in these following illustrations, there are many different processes that I think have possibly occurred in order to explain the mesh of Confusion Hill. Here we have some folding. Then we have a magma chamber, which has produced some dikes and some sills. And then the formation of a batholith. And the uplift of a batholith with some rotation. And some landslides or rock slides, which also have contributed to the formation of Confusion Hill. As mentioned before, I believe there were several geological processes that contributed to the formation of Confusion Hill. For example, here we have some folding, which is evident through the Kastner marble. I believe some type of sliding also contributed to the formation of Confusion Hill. As you can see, here are different types of slides, which may have contributed to the formation and the different rock formations found at Confusion Hill, which may have occurred millions of years ago as well. So I'm going to use this last slide to kind of summarize and explain the different processes that have contributed to the formation of Confusion Hill. So first of all, what I'm going to do here is I'm going to dome off this volcano so we can get a better illustration of our hill. And what I'm going to start off with is our intrusive magma chamber. As you recall, the Red Bluff granites have 5 intrusive stages. 5 intrusive stages, which all occurred at a different time, a different point in time. So what I'm about to explain are possible explanations as to the formation of these 5 different stages. So here we go. We have your intrusive magma chamber, which has produced some dikes, some sills across the older rock. Also, due to the heat from the magma chamber, there has been some type of contact metamorphism from the surrounding rock or the older rock, and as well as pieces of the older rock falling into the magma chamber. So as this magma chamber cools, you are left with your dikes once again, your sills, and your xenoliths. And all these are evident throughout Confusion Hill. Here you have a dike. Here you have your xenolith. Not only did this magma chamber produce this, it also has produced some type of uplift with some possible rotation to produce some folding and exposing the older rock, like the Kastner marble. I believe this uplift and batholith formation process has played a major or has been a major contributing factor to the formation of Confusion Hill. So here we are at Perfect Storm, Confusion Hill. There's a whole lot of mess going on in here. Hopefully I was able to paint a clear picture of what has contributed to the formation of Confusion Hill. So let's revisit what we have discussed. Confusion Hill is part of the Franklin Mountains. The Franklin Mountains are part of the American Rockies. The Confusion Hill can be found on Trans Mountain Road. There are three major types of rocks found in Confusion Hill. Your first one being the oldest, which is a Kastner marble, which is a sedimentary metamorphic rock. Then you have your basalt, your extrusive rock, which is the Mundy Breccia. And then you have your intrusive rock, which is the Red Bluff granite with 5 intrusive stages. And the factors or the process that contributed to this mess is, I believe, was some type of sliding, some type of folding, and this folding was also produced possibly by some intrusive uplifts throughout the different stages of the Red Bluff granite, the intrusive stages of the Red Bluff granite, which produce some dikes and sills and some xenoliths, and of course some contact metamorphism, which is also evident throughout the hill. I hope I was able to paint a clear picture of what were the contributing factors to the formation of Confusion Hill. Once again, there's a whole lot going on. Will we ever know exactly what may have occurred? Probably not, but with the information I gave you, I hope you have a good idea of what may have occurred. And this is it, and I just want to thank you for your time.